Hello and welcome to Bringing C and C++ Games to Android. I'm Dan Galpin. I'm a developer advocate on the Android team working with game developers. So about this talk, we're going to expect that you guys are C and C++ developers. If you don't know C and C++, you probably shouldn't be here. Hopefully you've gotten some Android background, because we're not going to cover all the basics here. This is considered a higher level talk. Game development experience is awesome. We're not going to teach you how to become a game developer here either. And however, we are going to expect that you may or may not have ever touched the NDK, or in that case, JNI. So our agenda for today is going to be programming Android and C and C++, using the NDK, bringing your game to Android, troubleshooting tips and tricks and tongue twisters, and best practices. So to start off, programming Android in C and C++. And I'm going to be joined, by the way, by Ian E. Lewis, who is also a developer advocate here on the Android team doing game development, helping out game developers. So to start off with, the NDK provides support for C and C++ development. NDK is the native development kit, and the idea is people write code in other languages than Java. I know, it's kind of shocking. And sometimes this code works and they want to reuse it. So we made the NDK partially because there's tons and tons of great code out there, whether it be open source code, whether it be code that you've developed that you're going to want to reuse. Also, as it turns out, Java is not the best language for everything. There are times when you're doing things that are really math sensitive. There are times in which you are doing things that are seriously hardcore, when you're going to want to accelerate things. And you want to take advantage of things like VFP. You're going to want to take advantage of things like Neon, okay, for super cool stuff. And of course, I have heard that there are other platforms that people write games for other than Android. And I know, it's shocking. But you might want to port those entire games over, and you want a method of doing that allows you to get high performance and consistent quality. So let me let Ian take it away from here, and he's going to talk about what's in the box.
I haven't been this embarrassed since I started teaching class at DigiPen and thought that it started a week after it actually did, and found out that all my students wanted to kill me. I apologize for being late, but yes, as Dan was saying, the NDK is a way to program C and C++ in Android. How many of you have used the NDK? OK, awesome. The rest of you, bless your lucky stars. The NDK was actually kind of difficult to use in the past. It's gotten a lot better this year, and we're actually pretty excited about the changes that we've made. But here's what the NDK is. Okay, it starts out with a tool chain. And if you're familiar with Linux programming or Mac programming, this sort of toolchain is not going to seem at all out of place. It's basically GCC and make and build and all these nice things that you're used to. It also has a build system. You're not actually required to use this as of NDK-R5. And at first glance, it seems a little over-engineered. But it's based on the same platform build system that we use for Android. And it makes it really, really easy to write modular code and build up an application of multiple shared libraries in C++. And I'm told that if you try and do the whole toolchain from scratch yourself, it's considerably more difficult. So you might want to at least start with the make files that we've got for you. And there's also a set of headers and libraries. So libraries that interface with the underlying system. Now, this is a really important point. In fact, it's actually the most important piece of the NDK. And you might be asking yourself, why? In fact, if you're like me, you're probably saying, well, wait a second. I heard Android's Linux, and Linux has always been C++, so why do I even need this stuff, right? Well, it turns out that although Android is based on Linux, Android processes have a very important difference. And that's that, we've always had the Dalvik VM, and every Android process loads the Dalvik VM. Application code is expected to run in the VM over the top of this set of frameworks that is the Android SDK in Java. Now, what the NDK is trying to do is let you get some code down here underneath that layer where only C and C++ code have been written before. And the problem with this is that for a long time, the Android operating system has been able to rely on this framework layer for backwards and forwards compatibility. So the problem with just sticking some code down there, which you can do, you're not dumb, you can compile C code on Linux, but if you do it without the NDK, you're going to have a real problem here. Because the set of system libraries that we talk to that implement the Android system in C and C++ have never been stabilized. There's never been a reason for them to be stable. We change them every time we revise the operating system. We're continually making them better and switching things around based on the needs of the underlying OS. So what we needed with the NDK more than anything else was to create a stable ABI. And with that stable ABI, then we could finally get the framework classes out of the way and let your application code live in both Java land or Dalvik land and C and C++ land. With the first revision of the NDK, we launched some basic libraries, basically the things that we thought were going to be most interesting to high-performance programmers. Obviously the basic stuff like libc, some math libraries, and OpenGL. Now with Froyo, we also introduced a library called libJNI Graphics, which let you talk directly to the 2D rendering layers, bitmap layer, as well as the 3D OpenGL stuff. And with Gingerbread, we actually made a concerted effort to make the NDK and the Android system in general more attractive to game programmers. So we introduced some new input models. We used libEGL, which is the standard way of getting OpenGL context. We introduced OpenSL. So finally, you didn't have to go back to Java just to do sound. And we introduced a library called libandroid, which allows you to access some of the SDK framework from C++. Most notably, it's now possible in Gingerbread to write an activity completely in C++. And it's also possible in Gingerbread to access the asset manager from C++, which if you ever tried to access the asset manager from C in previous versions of the NDK, it was incredibly difficult. So we're excited to see those changes. Well, now that we've talked a little bit about what the NDK is, we should probably make it really clear what it's not. This is not the end of Dalvik. Dalvik is still a great way to program Android, and it will always be the premier way of programming Android. You always have SDKs written in Dalvik first, but it does give you a way to write C and C++ code if you've got an investment in that. It's not always going to be higher performance. Dalvik is a fast virtual machine, and not everything is going to benefit from neon instructions or from hand-tuned assembly code. So it's not always going to be the right choice for every game. Is it the right choice for your game? That's going to depend on a lot of things. Keep this in mind. Dalvik is the premier development environment for Android. It's a productive development environment. It has garbage collection and lots of nice libraries. But on the C and C++ side, lots of programmers know C and C++ that don't know a Dalvik language. It can be faster, and it can leverage existing libraries like open source libraries that have been written in C and C++ and are available for free. So it may or may not be the right choice for you. Fortunately, you don't have to make an all or nothing choice. And we'll talk a little bit about how Java and C can coexist. By the way, I do apologize for my voice. I was way too enthusiastic yesterday. Woo, Google I/O. Let's talk about how to use the NDK. All right, first off, you're going to have to install it. This is a really simple step, unless you're on Windows, in which case you're kind of screwed. No, so on any system, you're going to want to make sure you've got Java and Ant up to date. I don't know, on my MacBook Pro, I had to do like a Mac ports get for these things. But on Windows, you're almost certainly going to want to download Cygwin. That's not a restriction we put on regular Android programming, but the build scripts for the NDK just have never been ported from Bash. it is actually possible to build without SIGWin. I'll mention a couple ways in a bit on how to do that, but it's highly recommended. So then there's a sort of a nice flow that we go through. You set up a project, you write some make files, you're gonna write some interface classes and glue them up with some JNI magic. And then you're gonna go into sort of your build, deploy, and debug cycle that characterizes any software project. Let's drill down on these a little bit. All right, to create the project, there's actually several ways you can do this. The one on the slide is the out-of-the-box way. You run Android create project, and that gets you, as I'm sure you're aware, an Android project. There's also a couple of third-party projects that I want to mention just because they're so cool. There's a product called VS Android on Google Code that will create an Android project in MS Build. So a lot of game developers use Visual Studio. If you like that sort of thing, that's a possibility. There's also a project called Sequoia that's part of the Eclipse project. If you load that as an Eclipse extension, it will actually help you create an NDK project using the convert to C++ project wizard in Eclipse. Can you tell I'm a Visual Studio guy because I just said wizard? Do they even call that in Eclipse? I don't even know. But it's going to create, either way, you're going to get a few different files created. There's an XML file that Ant uses. There's a couple of properties files that you usually don't need to care about. And you are also actually going to have to create a couple of files yourself, unless you use that Sequoia project that I talked about earlier. It's 2 make files. These are actually fairly standard make files in the sense that they use GNU make syntax, but they fit into that fancy build system that I mentioned earlier. So they don't require nearly as much work as a normal make file. The first make file is called android.mk. It's mandatory. The build system expects to find this, and if it doesn't, it will complain. And it just contains the names of the files that you're compiling and any flag overrides that you want to do. So you want to set C flags for your project, fine, you can do it here. There's also a somewhat optional make file called application.mk. The idea is you might have several modules in your application, several different libraries. Each one gets its own android.mk, and then the application.mk pulls it all together. But the application makefile also does some other important things. It's a place to set your global debug flag settings, and more importantly than anything else, it's a place to set up your STL. And one of the great new features that we've finally been able to add in NDKR5 is real STL support, including exceptions that you get with just this one line of code in your makefile. Now you need to write an interface. Because remember that unless you happen to be targeting the 4% of devices that run Gingerbread right now, you're probably going to want to start out in Java and then call into C++. So you write a Java interface that's going to wrap your C++ in something that looks like Java. And to do that, you use the native keyword. This is actually really easy. You just decide which functions are going to be implemented in C++, and then you use the native keyword to define those functions inside your Java file. After that, you just need to generate stubs in your C and C++ code, which you can do with a variety of tools. Eclipse has a tool for this. There's also a command line tool in the JDK called JavaH, and it just generates a file that looks a little like this. Remember that, oh, darn these little slides. Remember we had 2 public native functions in our sample code. If we pass the class with these functions in them to JavaH, it's going to generate code that looks like this. Basically, you have a couple of JNI export functions, and the names of the functions are a concatenation of the class path and the class name and the function name, all separated by underscores. And the parameters to those functions are transformed into JNI types that are in C, JInt, for instance. And then there's a couple of extra parameters. One's a pointer to a JNI environment, which is sort of the object that you use to talk to the Java system from C++. And there's also going to be a handle to your object. Or, if the function is static in Java, there's going to be a handle to your class. We'll show you how to use that in just a second. Now, you might be thinking to yourself, that looks really easy, and it is. Just by giving the function the proper name, the Java compiler and the runtime know exactly how to find it in your C and C++ code. And they find it with a name lookup in a vtable that's sort of automatically generated for you. But there are times that you might want to do this manually. For instance, let's say that you've got some functions that you know you want to implement in C, but you don't know exactly what the implementation is until runtime. A good example of this would be if you've got some really heavy-duty math library, and you've got an implementation that uses neon and another implementation that doesn't. Well, not all CPUs have neon, so you might want to delay the binding of that function until you know what your instruction set is going to be. If you want to do something like that, it's also actually fairly easy. You just make your own function table. It's just an array of structures that has the name of the function. It has this cryptic little string. That's just telling you what the function signature is. In this case, 2 integers, or a function that takes 2 integers and returns void. If you don't want to memorize this particular bit of gobbledygook, you can use a tool called JavaP to generate that. Or, once again, Eclipse has a menu item that does this for you. And then finally, the last thing in that structure is just a pointer to the function. Once you've created that table, when you're ready to register up your interface, you just call a function called register natives, and you pass in a pointer to that table that you created. And that way you could actually have multiple different implementations of the same functions inside the same library being hooked up at runtime to your Java code. Of course, it's cool that you can call C++ code from Java. It's also kind of nice to be able to go the other way. That's not super, I'm not going to tell you that's easy because it's not one line of code, but it is pretty straightforward. This is where we use that class or object handle that we talked about earlier. Using an object handle, you can get a handle to its class. Using a class handle, you can get a handle to a method. And once you've got a handle to a method, you can use a function on that JNI environment, one of the call method family of functions that differ by return type, and that allows you to actually make a call from C and C++ back into Java. Excuse me. So that's all the coding. Now we get to build, and that's pretty normal. If you've done any any Android programming before, you probably know the second 2 steps. It's the first step that's a little different. You run NDK build, which is a shell script that just launches all those make files, stitches everything together, copies everything to the right directories, and makes sure that all of the C and C++ code that you've compiled is where the packager expects to find it. Then run ant to package it, run ant install to deploy it, and we're ready to debug. This is actually the most important, cool thing that we've done in the past year with Android is we actually made it possible to run a real instance of GDB and do multi-threaded debugging on Android devices. The NDK GDB script is a shell script that does a whole lot of heavy lifting. It starts by sanity checking your setup and making sure that you can actually debug the code that you think you can. And then it's going to start your application and an instance of GDB server. A GDB server is this tiny little thing that just communicates with a real GDB across, in this case, a named pipe. Why is it a named pipe instead of a socket? So we don't have to ask for internet privileges to debug. So GDB connects to this named pipe on your host. It thinks it's a socket on the host because it's been aliased. And once GDB is running, you can attach to that with any tool that supports GDB. I know of at least 3. Eclipse supports GDB. Visual Studio supports GDB if you buy an add-on called WinGDB. Xcode, which I've never used, but I hear it's cool, also it supports GDB. So you can use these IDEs, or you can use the command line interface to GDB as well. Now I'm just about to turn it back over to Dan, and we're going to talk about some tips and tricks, and it's really actually the most interesting part of the talk. But before we do, I want to leave you with one tip of my own, just from experience debugging. Make sure that when you start debugging the NDK, you have a Gingerbread device. No matter what you're targeting, the debug support pre-Gingerbread was not phenomenal. Gingerbread changes all that, and it allows you to actually debug multi-threaded applications and have a hope of actually figuring out what's wrong with your code. So remember to do that, and then I'm going to turn this over to Dan for some ideas on how you can bring your games to Android.
Thanks, Ian. So this part of the talk is subtitled Saving Ian's Voice. And it's really great to have him here to talk about a lot of the stuff that's going on in the NDK. So this part of the talk, we're going to be talking about actually bringing your game to Android and what that actually involves. So let's first talk about what devices have been accessing Android market. This is basically the freshest data. It's a 2-week period. We published it just this week. And as you can see, it's really exciting. We've had great uptake for Android 2.2. 65.9% of devices checking into market are now running Froyo, and 94.7% are running Android 2.1 or higher. So this is fantastic, because it means that you can take advantage of many of the latest features of Android without having to eliminate much of the market at all. But native activity is just starting. Right now, we're at 4.3%. So for non-tablet specific titles, things that are not going to require honeycomb, we want to be able to take advantage of native activity when it's useful. And then I'll give you an example. How many people here have heard about the Xperia Play? OK, cool device. It has a touchpad on it. And that touchpad is only accessible right now through native activity. So a lot of people are in a position where they want to write an application that's compatible, that can take advantage of those touchpads, but they still want to hit the rest of the market. So let's talk about how to do that. So we can do something called platform-specific resources, and we can define Boolean values there. And this is how that works. We create resources in a values-v9 directory. Inside of there, we create 2 values, one called, in this case, at least Gingerbread, and the other one called not Gingerbread. From there, we can just go into the manifest. Now we enable one activity if at least Gingerbread is true, and one activity if not Gingerbread is true. Voila, we have an application that now can run native activity on Gingerbread and will run whatever standard activity on everything else. Now, there are some things you'll want to do in your native code to take advantage of this. Let me actually show you. That's what I was going to show you there. There are some things you're going to do to take advantage of this. One is you're going to want to create stub interfaces to your game engine. Obviously, you do not want to hard code the dependencies to native activity in your game engine and include the whole thing twice. It's going to make the download a lot larger. It also means maintenance can potentially be larger. So what we're going to do is we're going to create some stub libraries. We'll talk about that really fancy build system we had before. This is what the Android.make looks like now. As you see, it just contains a pointer to 3 other libraries we want to build. There's the application.make file. It actually lists each one of those libraries. Inside of the individual directories, we also have other make files. In the Android.make, we have this one. And in the native Android.make, we have this one. This one, of course, only refers to libraries that are in Froyo. And this one refers to libraries that are actually available in Gingerbread and beyond. And what's important is both of them use the same local shared library. And that's where the primary amount of our code will actually sit. So we do have one problem. And that is Android does not support dynamically loaded libraries that are automatically linked. We don't do dependency checking. So we have to have a way of loading that other library before native activity kicks off. The good news is that we actually provide a method for doing that. We can extend native activity. So all we're doing in native activity is creating a static member that loads our primary dynamic library. Now, in our standard JNI-based version, we simply load them in order. And that's it. With this, you can actually have two different activities that share the same native code path, but target different devices. Now, let's talk about what you need to do in order to write a game. Well, you need to deal with the Android lifecycle. You're going to have to deal with input, graphics, sound, and of course, assets. And the reason I want to bring up the activity lifecycle is it is so important. The framework does a lot to help you with the activity lifecycle. And I'm sure many of you have seen a diagram like this. Someone comes in front of your activity, it's visible, it gets shut down, it comes to the foreground, it gets restarted. All this stuff happens. And there's always one line that has been missing from this diagram, and that's this one. OK, and that happens when something in your process actually changes the configuration. So look at all the different ways your application can go through this chart. But here's what's interesting. There's only one in which your process actually gets killed. Most of the time, your native process is never going to get killed. Your library is not going to get reloaded. And this means that you actually have to be a little bit smart. Because Android tries to keep your process around for as long as possible. So even if you finish your activity, your native process is going to continue running. It's continue to get a bunch of CPU cycles. What does this mean? It means if you actually continue that running, it's going to be bad. Now, visible activities are given high priority. So it's not the end of the world. But it is something that is very important to note. So what does this mean? Be careful with static initializers. Your library will not be unloaded as long as your process is active. So this means that when your activity restarts, you need to be able to manually reinitialize anything that you might be relying on static initializers to do. So in general, don't use them. Also, be careful with threads, because threads are tied to your process. They'll continue to run even if your activity is ended. And what that means is that people will be using the device, and they'll find that it's slow and terrible, and they'll look in the battery life meter, and they'll realize that your application is the one that's sucking up all the battery life, and then they'll go on Android Market, and they'll give you a 1-star review and saying that you suck. I mean, they might do that anyways, but at least let's not give them a reason to do it. Other things to note is that gameplay should stop during on pause, but your application might still be visible. And I'll tell you the most standard way that can happen is if you're using in-app billing, it'll actually bring up an intent that'll cause an activity to show up not full screen. Well, your application is technically paused but still visible. So it might make sense to do some more stuff in on stop than you were doing it on pause. Still save all your state, but maybe you don't want to trash all of your GL variables in on pause in that case. Finally, in onDestroy, you want to make sure all your native code is cleaned up. And a lot of people are like, well, onDestroy never gets called, right? I mean, but it does. There are definite ways in which it can get called, especially if you're not handling orientation changes or changes in devices, like when a keyboard is attached or something like that, and it tries to restart your activity. So you've got two choices. You can either handle all those configuration changes, or you can be really, really vigilant about this. One of the two. So let's talk just go quickly about all the things you've got to handle. You've got to handle input. Okay? Key handling is important. A lot of devices have capacitive buttons. And what this means is that we actually made a change in Android 2 that said, instead of just relying on key down, we actually went and you had to get a cycle of on key down and on key up. This prevents you from accidentally swiping into a button and clicking it when you don't mean to a lot of the time. Doesn't mean that it doesn't happen, but it helps. Another thing to do is if you're going to do things like handle key repeats, use the actual functions that are built into the framework so you get the same key repeat counts and the same behavior you would expect from an Android application. Touch and multi-touch handling is similar. We have things like gesture detectors. Use those so that your application behaves like a non-native application whenever possible, when it makes sense. And then finally, and probably most importantly, dealing with multi-touch. Now, most devices now support multi-touch, and most devices can actually track distinct points. But you can query to find out whether or not that's true by checking this variable, feature touchscreen multi-touch distinct. You can also use it as a filter in Android Market. If you want to make sure your device supports true two-finger multi-touch, you can. We also added a feature in Gingerbread called Jazz Hands, which allows you to see if your application supports 5-finger multi-touch. So these are all things that you can do to help configure your UI to make sense for your user. Now, even if you don't support distinct multi-touch, you can do things like have virtual D-pads. You just want to put them in opposite corners of the screen so that they will never intersect. It is cool to handle things like trackballs for the devices that have them. I love it when it's an option. And of course, everyone's going to want to use things like sensors. When people want to take advantage of the accelerometer, the gyro, you just want to make sure that it's disabled when you're not using it. You're also going to want to make sure to Androidify your game. And what do I mean is don't break the hard buttons. So back should do something. There's nothing worse than you're on the title screen of a game and you hit the back button, nothing happens, and it just, the piezoelectric goes off to let you know that you're hitting the button, but the game is not responding or doing something. Make sure it does something. Menu should probably do something, and if someone accidentally swipes the home key, there's nothing worse than when the game goes away. So these are all, and volume buttons are very similar. We don't want to eat those messages. If you actually have to return them to the framework, and you want to set the volume control stream. And then again, don't let the hard buttons break your game. You want to save your state. It's very, very important. These buttons do things that are relevant. OpenGL. Let's talk very, very quickly about this. The coolest thing about OpenGL on Android is that you can actually create your surface inside of Dalvik and take advantage of it directly from within the NDK. And that's awesome, because actually, it's a lot of work to create OpenGL stuff, OpenGL context compatibly across Android. And GL Surface Hue, if you ever look at the source code, and of course, what's awesome is that you can, actually contains a whole bunch of stuff that you don't want to have to rewrite that works around a lot of issues that can possibly happen in the GL driver. So I definitely recommend using it. Now, it's not the most efficient way to multitask because it's going to automatically release your context during on-pause if you call its on-pause state during the on-pause. That's when it does the work for you. You might want to call it during on-stop if you know you're going to be using in-app billing. One thing to think about. But also with Honeycomb, you can actually say, I want it to preserve my state, and it will. So we added that as a feature in Android 3.0. And when your context is lost, you're going to have to do a lot of work. You're going to have to reload your resources, things like textures, buffer objects, and shaders, and your names don't even persist. So these are all things that are important to remember when you're using OpenGL. The marketing way of describing this is that Android encourages innovation in hardware. What this means is that you have a problem as a developer. You've got to deal with potentially different kinds of proprietary texture compression formats. And if you want the best quality, you will. Because your other solutions are not all that great. You can use uncompressed textures. But what that means is that you are going to get a lower frame rate because you're going to be using more memory bandwidth. You can use ETC1, but ETC1 doesn't compress all data very well. It's mostly good for data that does not have sharp color transitions, and it does not support alpha. You can use multi-APK, which, as we announced earlier, will be available soon. Or you can put textures on an asset server, detect support at runtime, and download to each device. In the previous session, for this one, we talked about how to securely deliver assets from an asset server in order to avoid people leeching bandwidth. So if you want to know about that, there's some information on that. So some small tips about drawing for performance. Draw order is important, especially if you're not on a tile-based renderer, or a specific type of tile-based renderer in this case. So definitely draw front to back. It really helps. VBOs are critical for performance. You want to avoid unnecessary state changes. And finally, you need to use power of two-sized textures. Because if you don't, it can either be very slow, or it's just going to take an enormous amount of memory because it's going to just scale your texture up to the next power of two-size texture automatically inside the driver. Or it's just not going to work. And then, of course, writing compatible shaders. And this slide is actually contributed by my friend Kim over at Sony Ericsson because they've done a lot of work on this. But it's very, very important to query for the number of attributes and the varying and the uniforms that are supported when you're writing your shaders. And just because they're there doesn't mean they're actually going to perform well. But if it's not there and you try to write a shader that does that, it's going to crash your application, and that's not fun. And of course, you want to avoid things like conditions and discard as much as possible, because it's really going to slow down the performance of your shaders. Mobile shaders are just in the beginning of their life cycle, and they are going to do very, very cool things. But right now, we have to be a little cautious when we write them. Quickly into sound. Android includes a bunch of options for sound. It can be a little confusing, so let's go through them super quickly. We have Media Player, which is really a full-track media solution. We have Sound Pool, which allows you to play sounds from memory. And it's actually the only way to play compressed audio from memory. That is not yet supported in native OpenSL. We also have, of course, Audio Track, which is something we introduced in Android 1.5. I think. And it allows you to play PCM audio only with minimal latency. And it's really meant for applications that are generating their own audio. And finally, we have OpenSLES, which does require Android 2.3 or higher, but it combines the capabilities of Media Player and Audio Track, and it allows you to do all of your audio from native code. And the interface is actually a little nicer in terms of generating audio, because it actually calls you back when it needs a buffer. So it's a very, very straightforward interface to use. And I'm sure going forward, it's going to become even more and more powerful and important. So let's talk quickly about assets. One of the things that people want to be able to do is pull resources and assets out of their APK file. And I went to the Android team and I said, all right, there are many ways we can do this. What is the way that is most likely to still be compatible in the future? And they suggested this method. So what we're going to do is get our APK file name using this source dir. Then we're going to use the asset manager code. And that asset manager code allows us to get something called an asset file descriptor. All an asset file descriptor is a standard native file descriptor that includes extra parameters for offset and length. We can read them, open the APK file from that offset, and there we are. We're reading our resources right out of native code without any additional overhead. And the overhead we're trying to avoid, of course, is having to buffer things between Dalvik and native code. You can, of course, use a native zip utility in a very similar way. It's a little less future-proof, but it's probably going to work as well. And it's probably going to be faster, as long as you do things like cache the zip directory. And then finally, of course, you can use native asset manager on Gingerbread and beyond. All right, my tongue twister slide. Troubleshooting tips and tricks targeting tricky trying tasks. So threading Dalvik in the NDK. All contexts are per thread. You've got to be careful to check your threading. If you take that same context and reuse it across multiple threads, bad things will happen because the JNI context tries to do smart stuff for you, like clean up objects that you're not using anymore. So you want to use one JNI context per thread, or you want to take advantage of a game loop that actually takes your messages, threads them into another thread. It's also useful if you're calling the framework, because many of the framework classes don't like to be called from anything other than the UI thread. As far as performance, you can check for older hardware. And there's multiple ways of doing that. Checking for ARM7, checking for support for OpenGL 2, and then you can use fallbacks. You can do things like 16-bit textures. You can actually convert them on the fly using Bitmap Factory. You can also use a smaller render target using surfaceholder.setFixedSized. Of course, there are other ways of doing that within OpenGL, but this actually does it at the optimal place, which is at the compositor. Pixels are very, very expensive, especially on tablets. So this really will help. But if all else fails, we do have market filters, such as device availability, which was announced today, platform release, GL version, and instruction set. And you can filter on instruction set by only building a library for ARM5 or ARM7. And here are just general tips. Start small. Don't make me download a big file. Use the backup restore service. Support multiple control schemes. Install the SD. I'm not going to go through these. But you should all consider these. Things like profiling, make the game render up and do better stuff if it detects that it's running on a cool system. Hooking into social networks is, of course, really important for viral spreading of your application. Building a live wallpaper is so cool, and so few applications do it. But isn't that awesome? You get to own the user's home screen. I mean, what other platform allows you to do that? That's so awesome. Analytics, definitely. Find out where your customers are. Find out how they're using your title. This is awesome, awesome information. Find out where, use it to do things like finding out even where someone is dying in the middle of your game. You're like, hey, that level's way harder than I thought it should be. What's going on? Or only on this device, people are having problems. All that kind of stuff you can find out. And of course, in-app payments. We went through that in the last presentation I just did. We are now seeing amazing traction in in-app payments. If you look, we just added a new category on market for top grossing applications, and 3 out of the top 5 are top grossing only through in-app payments. So some tools. I'm going to throw these up here very quickly so that when this is played back and put on the web, you'll be able to get these. But this is some of the stuff we've talked about. And of course, we have some performance tools. Each one of the chipset manufacturers has now come out with performance tools, and they can be very useful. Some of them require a rooted device. Now, we've got a very short period of time for Q&A. So I went through those a little fast at the end. So if you have a question, this is the time to stop me on it. And thank you very much. And I recommend everyone stay around in the room after this, because there's going to be something special for all of you. So, free cake? That sounds good to me. All right, next.
Hi, I work on the open source port of FreeCiv. If I can just give a quick shout out. So that's
awesome.
Also, it's open source. It's, I think, one of the largest NDK applications. You can freely get the source too. There's a lot of terrible ideas in there, but hopefully there's one or two good ones.
Cool.
I had a quick question. It was something I'd seen when loading resources. One of the goals of that project was to be able to drop my app, even let it be killed, and have it like spring back as quickly as possible to where you left off.
Right.
And so I spent a lot of time optimizing how I loaded my art assets.
Mm-hmm.
I found something really counterintuitive. It seems JPEGs load about 3 times faster than PNGs. Is that sensible?
Is that based on the file size?
What I found was when benchmarking, this is on a Samsung Tab, was only about 1 millisecond per file was taken up in file I/O, and that was effectively the same whether PNG or JPEG. Definitely the PNGs were larger. The JPEGs were smaller. It was the actual, apparently it was the actual time spent like converting from the compressed stream into a bitmap.
Interesting. I haven't experienced that, but
PNGs aren't on the no compress list, are they?
No, yeah, they're both on the no compress list. Yeah, so that's the only thing that would cause that normally is that in the zip file, resources can be compressed, but both of those files are automatically not compressed. I'm pretty surprised you're saying that, but I don't actually know the answer to that. But it's a cool thing to note.
Even shifting that around, it didn't, like if I was on the SD card, the only thing is if it's on the SD card, it would seem to take about twice as long as if it was on flash memory.
Yeah, so that would really make me think that it actually was in some level file I/O. It might be even just because that would be my first guess is it's entirely I/O bound. But
at 3 times, and I mean, these weren't very large files.
Yeah.
I mean, I don't know. And it could also be, I know that's the OMAP platform and they have optimized JPEG decoders, so it may be offloading some of that to a DSP.
I don't think so, but that's it. I think
it could be loading it through an optimized code path.
It could be loading it.
There are 2 different code paths for it, but.
Yeah, I did actually try compiling the libjpeg and using, like, instead of loading it from Java, pushing it into a texture and then pulling it up through there. Yeah. I tried the libjpeg thing, and it even seemed like using just a bog standard compiled libjpeg performed better than PNG, but performed worse than pulling it up through Java. So, anyways, all right. Well, thank you.
No, that's interesting. That's good to know.
It's a mystery.
It is.
Short question. I have done NDK using the JNI, but I found out that debugging is extremely difficult. So I saw that we can do the complete Android application in C and C+ only without using Javas. So that makes the debugging much easier. Can you show me some way, or in the future we can support only C and C+ for Android application?
With Gingerbread, you can support that, but let me sort of lay things on the line for you. The debugger for C and C++ is honestly a little flaky. Every single version gets so much better, it's just amazing. But it also depends a lot on what you're using with it. So for instance, were you using like stock GDB, or were you using Eclipse, or?
Yeah, many use Eclipse, yes.
Okay, so right now, if you use Eclipse, and you either, there's instructions on the internet for how to get it to work with NDK GDB, or you can also use NVIDIA's plugin for Eclipse that sets up the debugger for you. The only disadvantage to that is your device has to be rooted right now. Hopefully they'll fix that. Then actually it's fairly easy to debug. You can bounce back and forth between Java and JNI, and your C++.
Yeah, there's no. Well, I was going to say that the main answer is that there's really no reason why you can't debug native code that's being called from JNI. It actually works. It works, as far as I can tell, just as well as fully native code.
Yeah, and the bad news is going to full-on C++ would not help anything, because it's not bouncing back and forth between Java and C that's the problem. It's just the debug layer in C is a little flaky with Eclipse.
Okay, thank you.
I had a question regarding Google TV and the NDK, and that after talking to the Google TV guys, the NDK is not supported for Google TV. Is that ever going to change? And
I think that's kind of up to the Google TV team. As a C and C++ developer, I would love it to change, but that's up to them.
Yeah, actually, you're not the first person to ask this question. Yeah. And I've worked closely with the Google TV team. They're not making any announcements. They haven't ruled it out one way or the other. But they have said on many occasions that they understand that it's a desire that a lot of people have.
yeah, especially with regard to some sort of like Xbox Live Arcade style gameplay.
Absolutely. No, I'm there with you.
We think that would be cool too.
So with each version of NDK, you guys are really progressing. With version 5B, you really crossed Crystal X, so good direction. But the question is about accessing the media player, the video playback actually from native code.
Yeah. So right now, there's no way to do it directly. I'd love to see that change, but that's still the way things are. So you still have to go back and bounce back into Dalvik to do that.
But that's on your roadmap, right?
I would really like it to happen.
First of all, let me say thank you for multi-threaded GDB and Gingerbread. Before it was just a pain having to call things on the main thread.
Thank David Turner and the Dalvik and the Android kernel team. Actually, they made that happen. They're both awesome.
I actually don't work on games, but I ported an extremely large engineering app from C++. And we needed, we were using the Christex before because we needed wide string, and we needed like a full STL. But for Gingerbread, we've actually switched now to using the STL. But the problem is the one that's part of the NDK5 doesn't export any of the actual W string functions. It builds, but it doesn't link to W string. And I tried really, really hard, and I looked around, and eventually what I had to do is I had to download the NDK source code and change the build scripts to get W string to export. And it's like 1.5 meg bigger, and it's fine. But actually, my question is this. So I changed that. Do I have, I need to ask a lawyer this, but do I have like an affirmative GPL obligation? Because I only changed the build scripts. I didn't change GCC, but I'm using my own version, I guess, now of the NDK, not the source, not the one that was.
Well, all of I'm not an attorney, but my understanding is that all of Android is licensed under a license that doesn't force you to contribute your changes.
Because I didn't know
So
if like GCC,
yeah, if you're using the GCC stuff, it's interesting. I don't actually know what the answer is. I'm not on that. But I'm surprised the wide string stuff isn't working. We should file that as a bug because it is supposed to work. So that was one of the desired changes.
I talked to David about that.
Yeah.
And I think now he said that he actually couldn't get the command line. That there were like two mutually exclusive options.
Yeah.
Where wide string
And actually,
didn't work.
there are, and I actually had to hard code one of them. They're like Boolean opposites, and I went into one of the make files, and I figured, and I basically had to manually override it.
Right.
So this is really good. This is one of the things that you should speak up on the forums or email us about, because as you can see, so really difficult build solution that ends up making your code 1.5 meg bigger, and maybe isn't all that desirable by most people.
Yeah.
You can probably see why that choice was made.
Yeah, absolutely.
But if we've got more feedback about that, more data points, that might be something we want to support in the future.
Absolutely.
Thanks.
Quick one. Any plans to access the camera API through native code?
It's another nice to have. I think ultimately here's the issue. I mean, the general thought is if there isn't a strong performance reason, for the most part, the goal is to make it something that you have to get through Dalvik, because that is the primary platform for development for Android. That being said, there's a lot of people who want to do really cool stuff with the camera that if you had a native interface, you could do it a lot better. So I think that's an important one to bring up. And again, keep requesting it, keep complaining about it. Hopefully it'll happen.
Thank you.
All right, so that being said, I'd like to mention that how many of you guys here are game developers or want to be game developers? Okay, well,
Everybody wants to be a gamer.
well, yeah, well, you know, it's a tough job. So we have something very special for you. Sony Ericsson has come today, and they are here to make sure that every one of you has the ability to develop really, really great games. And so they want you to have a device that has support for a modern GPU, has support for a lot of different controls. They want to see what you can do with it. So without further ado, on your way out, you will be getting a card, and you'll be able to exchange that card for your very own Xperia Play. So our only ask is that we want to make sure you guys do really, really cool stuff with it. If you do, and you're going to want to go a couple things. One is you're going to want to go to SonyEricsson.com developer, and they've written a lot of articles about how to get to the special features of that device. The second thing you're going to want to do is if you do something cool, go to standout.sonyericsson.com and let them know that you've done something cool, because they're always looking for people who are doing cool stuff with the Xperia Play. So with that, I hope you all enjoy it. I'm very excited and a little jealous for you all. And there we have it.
Thank you.
Thank you.